Welcome to ZICA Academy YouTube channel. In this lecture, I want to examine how to estimate the seasonal variation using the multiplicative model. This is my fourth video on the topic. In the first two videos, I've examined how to estimate the trend. In the third video, I dealt with how to estimate the seasonal variation using the additive model. In this fourth video, I want to consider how to estimate the seasonal variation using the multiplicative model and how to make use of the estimated figures in financial forecast. So, now I've told you that seasonal variation is the regular rise or fall in time series data. In my earlier video, I've told you that the estimation of seasonal variation depends on the model required under exam condition. And I told you that we have two models. Number one, we have the additive model. Additive model. Under the additive model, I told you that time series value equals to trend plus seasonal variation plus cyclical variation plus random variation. And I've told you the first two variables are the most important ones. Then the second model, which I'm going to consider in this video, is multiplicative model. Remember, additive model have been used in my earlier video. Now I want to consider the multiplicative model. And I've told you that under the multiplicative model, time series value equal to trend times seasonal variation times cyclical variation times random variation. Of these four variables, I've told you the first two are the most important, that is T times S, trend times seasonal variation. So in my first two videos, I've dealt with how to estimate the trend using, number one, the moving averages method. Number two, using simple regression method. So I want to deal with the estimation of seasonal variation using the multiplicative model. Multiplicative model is used where the seasonal variation is given in percentage, where seasonal variation is given in percentage or decimal number that is preceded by zero. Decimal number preceded by zero. Decimal number such as you have 0.40, 0.70, 0.65. So these are decimals. Or it might attract plus or minus, so it doesn't matter. So if it is decimal like this or percentage, let's say minus 60%, then you are expected to make use of the multiplicative model. Yes. For estimating seasonal variation by multiplicative model. When you are using multiplicative model, so what are the steps for estimating the seasonal variation? Step number one, estimate the trend in the data. Estimate the trend in the data. I've told you you can estimate the trend by moving averages method, or by regression method. So under the regression method, sometimes you'll be given the equation. and where the equation is given. So you can use that equation given to estimate the trend. You may be given S equal to 5 plus 3x, or y equal to 5 plus 3x, or any equation. So when you are given those equations, use the equation to estimate trend, or you go by the full procedure in estimating trends, such as the moving averages method and the regression method. The second step, calculate the variation or deviation of each quarter. Calculate the deviation or variation in each quarters or data in each quarter using y over t, or if you like, you can take the result to percentage, where y equal to actual sales, and t is trend. If you go by the first video, the video I have on additive model, we have y minus t, but this is in fraction now, y over t, so which is actual sales over trend. That is the second step. Step 3 is to find the simple average. Find the simple average of y over t, that is, of the result obtained from step 2. So you find the simple average. Step 4. Let me continue that step. Find the simple average of y over t and sum them up. You add up the averages obtained. Step number 4. Then if the sum of the averages obtained in step 3 is not equal to 4, not 0 this time around. If you look at the additive model, we want to consider whether the sum will be equal to 0. But in terms of multiplicative model, we want to look whether the sum will be equal to 4 or 400%. If the sum of the averages is not equal to 4, that is, if you work on decimal, you consider 4. Or if you are working in percentage, you consider 400%. If the sum is not equal to 4 or 400%, adjust one or more of the averages so that their sums add up to 4 or 400%. I've told you 4 for decimal, 400% for percentages. Number 5, prepare a forecast using the multiplicative model. That is, trend times seasonal variation times cyclical variation times random variation. If these two are to be considered, we have T times S. So we prepare a forecast using this formula. Example 1. The sales of a company Y in 1,000 naira are given below, together with a previously calculated T. Sales Y, trend T. We have year 1 and year 2. We have quarters. In quarter 1 of year 1, 20, and trend 23. In quarter 2, sales 15, trend 29. In quarter 3, sales 60, trend 34. In quarter 4 of year 1, sales 30, while trend is 39. In year 2, in the first quarter, we have sales to be 35, while trend is 45. In quarter 2, we have sales of 25 and trend of 50. In quarter 3, sales of 100 and trend of 55. In quarter 4 of year 2, we have sales to be 50, while trend is 61 required. Using the multiplicative model, calculate the average seasonal variation figures. Now, let's have the solution to the question. Solution. We have Y, which is our sales. We have trend, which is T. We have quarters. Quarter 1, year 1, quarter 1, 2, and 3, and 4. The sales for quarter 1, we have 20, trend, 23, 15, 29. 20, 23, 15, and 29. Then, in third and fourth quarter, 60, 34, 30, 39. 60, 34, 30, and 39. Then we have year 2. 1, 2, 3, 4. So, we have 35, 45, 25, 50. 35, 45, 25, and 50. We have 100, 55, 15, and 61. 100, 55, 50, and 61. Then we want to calculate the deviation or variation. I've told you under the multiplicative model, I say it is Y over T. This is Y and this is T. 20 over 23. 20 divided by 23, that gives us 0.87. If you take it to percentage, it will be 87%. 15 divided by 29, that gives us 0.52 or 52%. 60 divided by 34, that gives us 1.76 or 176%. 30 divided by 39, that gives us 0.77 or 77%. We have 35 over 45. That gives us 0.78 or 78%. This will be 0.50 or 50%. 100 over 55. That gives us 1.82 or 182%. Then 50 divided by 61. That gives us 0.82 or 82%. Then that is the first step. Then the next step is to estimate the deviation. You estimate the quarterly deviation. You have quarters, 1, 2, 3, 4. Let me include total. Then we have year 1. Year 1, we have 0.87, 0.52, 1.76, 0.77. 0.87, 0.52, 1.76, 0.77. In year 2, we have 0.78, 0.50, 1.82, 0.82. We have 0.78, 0.50, 0.50, 1.82, and then 0.82. Let's find the total for each quarter. They have totals. 0.87 plus 0.78. That is totaled 1.65. 0.52 plus 0.50. That gives us 1.02. 1.76 plus 1.82. That gives us 3.52. Then 0.77 plus 0.82. That is total 1.59. Let's find the averages of this. To find the average, you divide, since 2 years are involved, 2 items divided by 2. So 1.65 divided by 2, that gives us 0.83. 1.02 divided by 2, that gives us 0.51. Then 3.52 divided by 2, that gives us 1.76. 1.59 divided by 2, that is 0.80. Now, let's sum up the averages. 0.83 plus 0.51 plus 1.76 plus 0.80. We have 3.9. The total is 3.9. Not equal to 4. This 3.9 is lower than 4, though it is approximately equal to 4. So it is lower than 4 by 0.1. If you subtract 3.9 from 4, the difference is 0.1. Then you will need to adjust one or more of these averages so that the total will be equal to 4. I've told you, if this figure have been calculated in percentages, then that means you'll be working towards 400%. You need to have the adjustment table. You have quarters. 1, 2, 3, 4, and total. The averages were given. That was calculated. The averages we have 0.83, 0.51, 1.76, 0.80, and total is 3.9. So averages we have 0.83, 0.51, then 1.76, then 0.80, and 3.990. For this to be equal to 4, if you have 4 minus 3.9, that will be 0.1. That means you will need to add 0.1 to it. If you add 0.1 to this, it will be 4. Then you can now add that 0.1 to one of these averages, or divide 0.1 by 4 and add it to individual quarterly average. But since 0.1 is small, I want to add it to this. This is adjustment. So the adjusted value will be 0.83, 0.51. Then this will be 1.86. 1.86. This will be 0.80, and this is 4. So this is seasonal variation. This means, notice is lower than 100% by 17%. It means to obtain the sales for quarter one, that you should deflate the quarter one trend by 17% or 0.17. If you subtract this from 1, 0.17 or 17%. Note this figure is, if it is percentage, this will be 83%, which is lower than 100% by 17%. You deflate quarter one trend by 17%. That is, calculate 83% of the trend given in quarter one. If it is quarter two, calculate the trend in quarter two, calculate 51% or 0.51 of quarter two trend, or deflate it by 49%, and so on. Then this one, you increase quarter three trend by 86% to get the sales of that quarter. So this is the solution to example 1. Example 2, the quarterly sales of a product are monitored by a multiplicative time series model. The trend in the sales is described by y equal to 100 plus 5x, where y denotes sales volume and x denotes the quarterly time period. The trend in the sales for the most recent quarter, first quarter of 2020, when x equal to 20, was 200 units. The average seasonal variations for the products are as follows. Quarter, first, second, third, and fourth. Seasonal effect in the first quarter is 0. Second quarter, minus 20%. Third quarter, we have plus 40%. And the fourth quarter, we have minus 20%. The price of a unit was 1,000 naira during the first quarter of 2020. This price is revised every quarter to allow for inflation, which is running at 2% a quarter. Required. Produce sales volume forecast for the 3 remaining quarters of this year, both actual and deseasonalized. B. Produce forecast for actual sales revenue for the 3 remaining quarters of 2020, stating any assumptions. Back to A. You want to produce the sales volume forecast for the remaining 3 quarters. You were given the formula y equal to 100 plus 5x, and you were told y denotes sales volume and x denotes quarterly time period. And if you look at the requirement A, you have to produce sales volume forecast for the 3 remaining quarters. That means you have to produce the value of y. Back to, let's have the solution. Solution, we have y equals to 100 plus 5x. You were told the value of x in the first quarter 2020, when x is 20, was 200. If x is 20, 5 times 20, that is 100. 100 plus 100, that is 200. That is how they got the 200 here. But for the second quarter, if the first quarter is 20, the second quarter will be 21, the third will be 22, while the fourth will be 23. So first quarter now, first quarter. So this is analysis. You have to obtain this is analysis. That means you have to obtain the value of y. So that means y will be 100 plus 5x, where x equal to 21 for the first quarter. For the second quarter. If the first quarter is 20, second quarter now will be 21. So we have y equals to 100 plus 5 times 21, which is 100 plus 5 times 21 will be 105. If you add it together, therefore y will be 205. So our decision analysis is 205 units. This is the decision analysis volume. Then what is the actual sales volume now? Actual sales volume now, you are going to adjust for seasonal variation. In the second quarter of the year, we have minus 20%. Minus 20% means you should subtract 20% from 100%. That means you'll be left with 80%. So our decision analysis, our actual sales will be 205, which is our decision analysis, times 80%. So we have 164 units. That is our actual sales volume after adjusting for seasonal effect. Then third quarter, the value of x, if second quarter is 21, the third quarter will be 22. So substitute 22 for x in the same formula. Y equals to 100 plus 5x, where x is 22. We have 100 plus 5 times 22, which is 100 plus 110. Therefore, y equals to 210. This is our decisionalized sales. So our actual sales volume now, you adjust for seasonal effect, which is 210 multiplied by, in the third quarter, the seasonal variation is plus 40%. Plus means you add it to 100. If it is minus, you subtract it from 100. Plus, you add it to 100. So you have 140%. 140%. Calculate 140% of 210. So we have 294 units. That is the actual sales volume in quarter 3. In the fourth quarter, x will be, if for the third quarter we have x to be 22. So in the fourth quarter, x will be 23. So using the same formula, y equal to 100 plus 5x, where x is 23, we have 100 plus 5 times 23, which is 100 plus 5 times 23, that gives us 115. You add it together, you have y to be 215. This is our decisionalized sales volume. So our actual sales volume now, you adjust for seasonal effect, which is 215. Now, seasonal variation in the fourth quarter is minus 20%. If you subtract 20 from 100, you'll be left with 80%. So you calculate 80% of this. 215 times. So you have 172 units. That is the actual sales volume. That is the solution to the first part of the question. Now, in B, you are to produce forecast for actual sales revenue for the 3 remaining quarters of 2020, stating any assumptions. You want to calculate the actual sales revenue for the remaining 3 quarters. You were told the price of a unit was 1,000 during the first quarter of 2020. First quarter, you have price to be 1,000 naira. You were told this price is revised every quarter to allow for inflation, which is running at 2% a quarter. So second quarter, if inflation of 2% has occurred, times 1.02, that gives us 1,020 naira. This is price. Then third quarter, which will be 1,020 times 1.02. We have 1,040.2.4. In the fourth quarter, you have 1,040.4 times 1.02. You have 1,061.21 approximately. You have to produce forecast for actual sales revenue for the 3 remaining quarters. Forecast of actual sales revenue. Forecast of actual sales revenue. So for the remaining 3 quarters. So quarter 2 now, the selling price for quarter 2 is 1,020 naira. 1,020. The number of units sold in quarter 2. So we have 164 units. 164 units. 1,020 times 164. So we have 167,280. So the third quarter of the year 2020. The selling price is 1,040.40. 1,040 naira 40 kobo. The number of units sold, actual sales volume, is 294 units. 294 units. We have 1,040.4 times 294. That gives us 305,877.60. Then the fourth quarter of year 2020, the selling price is 1,061.21. 1,061.21 times the units sold, the actual sales volume in the fourth quarter of year 2020 is 172 units times 172 units. So 1,061 0.21 times 172. That gives us 182,528.12. Now, what is the total? Let's sum them up. Plus 305,877.6. 877.6 plus 167,280. We have 685,685.72. So we have forecast says revenue for the remaining 3 quarters. For the remaining 3 quarters of the year 2020 is 655,685.72. Now, back to the requirement. You have to produce forecast for actual sales revenue for the 3 remaining quarters of 2020, stating any assumption. So that is all about the requirement. So this marks the end of the solution to the question. My next video, I will consider a situation whereby you will need to estimate both trend and seasonal variation together, and then we make use of them in our forecast. Please make sure you drop the love emoji, share the video with others. Thanks for watching ZICA.